This is a lecture on applications of differentiation. Before we study applications of differentiation, let's consider some preliminaries. Firstly, what is the gradient of a straight line? Suppose that you know 2 points on a straight line. So let's denote the coordinates of the first point as x1, y1, and coordinates of the second point x2, y2. So x1, y1 and x2, y2 are just numbers, real numbers. And we want to know the gradient of the straight line, knowing the 2 coordinate points. The gradient of the straight line can be computed by taking the difference between the y values. So we will take y2 minus y1 over x2 minus x1. Notice that we've taken the difference between y2 and y1. We take the difference in x in the same way, x2 minus x1, taking x2 first followed by x1. So let's put some numbers into x1 and y1. Suppose that x1 is 1 and y1 is 2. Suppose that x2 is 3 and y2 is 5. So obviously the gradient can be computed then by taking the difference in y values, y2 minus y1 over x2 minus x1 to give us an answer of 3 on 2. Now let's look at this expression for gradient in more detail. y1 is the vertical height of point 1 from the horizontal axis, and y2 is the vertical height of point 2 from the horizontal x-axis. y2 minus y1 is the difference between those two vertical heights, i.e. the vertical distance between point 2 and point 1. Now x1 is the horizontal distance to point 1 from the y-axis, and x2 is the horizontal distance to point 2 from the y-axis, and x2 minus x1 is the horizontal distance between the 2 points. And the gradient is given by rise over run, which is the height of the red line over the height of the green line. So we could compute the gradient quite easily if we know 2 points on a straight line. Okay. Now how do we find the equation of a straight line? Suppose that this straight line cuts the y-axis at some point C, and suppose that we are given the gradient of this line. So suppose the gradient m is given, and the straight line cuts the vertical axis at point C. The equation of the line can be written as y equal to mx plus c. So to put some numbers in, suppose that the straight line cuts at the point 2 and the gradient of the line is, let's say, m is 3. Just to put some numbers in, the equation of the straight line can then be written as y equal to m, the gradient is 3, which is given to us, x, plus the straight line cuts the y-axis at point at a height of 2, so c is 2, so we could say it's y equal to mx plus c, m being 3 and c being 2. So that's how we find the equation of a straight line. That's method 1. If you know the gradient and if you know where the straight line cuts the x-axis, we can write the equation of the straight line according to y equal to mx plus c. Method 2, suppose that we are given the gradient. So let's say we know that we are given the gradient of the straight line and we are given a point on the straight line. So we know x1, y1. So m is known, x1 and y1 are known, so there are some values. How do we find the equation of this straight line? Equation of the straight line is y minus y1 is equal to m times x minus x1. So if we know m, the gradient of the straight line, and if you know point x1, y1 are known, then we can write the equation of the straight line according to this expression here. Now if we put some values in, suppose that x1 is 1 and y1 is 2, and suppose the gradient is 3, and those numbers are given to us, and we could find the equation of the straight line according to this expression that we see here. Y minus y1 is 2 equal to gradient, which is 3, x minus x1, which is 1, which we can simplify further. The right hand side we have 3x minus 3 and this minus 2 on the left hand side. If we take it to the other side, it becomes plus 3, so we would obtain y equal to 3x minus 1 as the answer, as the equation of the straight line. Equation of a straight line, method 2, method 3, we looked at 2 methods so far. Suppose you're given 2 points on the straight line, so you're given x2, coordinate x2 and y2, and coordinate x1 and y1, and we want to find the equation of the straight line. We know from our discussions so far that the gradient can be computed by y2 minus y1 over x2 minus x1. Knowing 2 points on the straight line, we can compute the gradient, and knowing a point on the straight line, we could write the equation of the straight line as y minus y1 equal to m x minus x1. So since we can compute m knowing 2 points on the straight line, we can compute the equation of the line according to